because we're only going to have to worry about talking about 3 scenarios. What I mean by that is only 3 sets of things have to be congruent. And when we get into this, this is where we start talking about what we call the alphabet soup of how you prove triangles that are congruent. Between today and tomorrow, we'll go over the 4 major ones. On Wednesday, we're going to mix them all together. I might add in one other. There's only 5 ways we need to do this. And the way that all of it works, pretty straightforward. There's really no weirdness here. The idea of understanding which one you're working with is the idea of knowing how to work with a picture. How do you mark the diagrams correctly? And then which of the 5 scenarios you wind up with. And it's just a matter of looking at the diagrams. How things get proved, we're still going to use progression sheets. If you're given a midpoint, state the segments, what segments are congruent to each other. If you're given an angle bisector, so on and so on and so on. We use all of those same exact things here in the next few days. Generally speaking, this first setup is pretty quick, and there's not a whole lot of weirdness to it. It's the later stuff where you add more steps to it, which starts to get a little weird. So what I want to do is I'm going to set you guys up with another short quiz this week, but this week will be on Thursday. Okay. And that'll be just trying to, again, you've got your progression sheets, all that stuff. It's very, once you start seeing what we're doing, you'll be like, oh, that's all this is. And you're like, yeah, that's all it is. There's not a lot of thinking going on. Then come Friday, we'll start doing what's called corresponding parts. It's all the exact same stuff that we were doing all 3 or 4 days this week, but you add 2 steps at the very end. Okay, it's not as crazy as it sounds. So let's talk about the idea here of what's called congruencies of triangles. So if you have if you have 2 triangles, and I say I have triangle ABC and X, Y, Z. If I only know that there's correspondence between sides, A and B, X and Y, if I know that, if I know that all 3 sets of sides are congruent to all 3 sets of the other triangle, those 2 triangles wind up being congruent to each other because of something called side, side, side. I know, that's what it's called. So we move this up a little bit so we can get this all to fit. So yeah. So I can say triangle ABC is congruent to triangle XYZ. Notice how the lettering matches. Segment AB matches to XY, BC to YZ, CA to ZX. That's why we always talk about correspondence of letters. Those letterings match up. Those tick marks match with the letters. We know that these 2 triangles are congruent because of what's called side, side, side. Yes, sir. Yep. This is kind of like that. So what I want to do is on our progression sheet, I'm going to make a triangle, or not triangle, a box, and I'm going to call it ways to prove triangles congruent. And there's going to be 5 total ways to do this. So what I would do is not take up a whole square for it for all these different ways. That way we can make we'll make a running list of them. Okay. So one of the ways we'll do it is side, side, side. And I'm going to put a picture of it. That way you know what it looks like. That way you know what it looks like. Yeah, I didn't say that you had to rewrite them. I was just saying that a lot of times it's an easy way to study for it because that way you remember where everything is on your sheet. Okay. So like I said, there's going to be 5 different ways. So I'm just going to make a running tally sheet on one of my squares of ways of showing that the triangles are congruent. The first one today is going to be what we call side, side, side. Okay. Might as well put just leave it up here then. I might come back to it. That's what that looks like. Okay. So what'll happen then is just like we've done in proofs, you can have something that looks like this. So let's write this out. We'll go through a proof and show you guys how this goes. Wrong class. Whose progression was this one? We didn't get theirs back. We got one roll. So now instead of proving stuff with the algebra or segment addition, angle addition, going back and forth, substitutions, whatnot, now you have an end goal in sight that you can mark on a diagram and you can figure out what you need left. Because depending upon the information that you're given, you'll have one of those 5, usually 4, ways that you'll be able to set these things up. Give you guys a second here to fix right in. Oh yeah. So here's what we got. Why do I write down LM is congruent to NP? I am given that. So as soon as I'm given something, I make sure it's marked in my diagram. Well, I look at the diagram. Is LM tick marked to match up with NP? Yes. Okay. Not always will that be given to you in a diagram. You'll have to physically go there and go, oops, there's one here and there's one here. Okay, so I'm there. Is there any progression after stating 2 segments are congruent to each other? Nope, nothing I can do. No definition. I said means I go to the next one. LP is congruent to NM. Well, again, it's given. I go to my diagram. It's marked. I need to figure out a way to show that those 2 triangles are congruent to each other. On your progression sheet, you probably have a picture that looks somewhat similar to that. And it tells you for something to look for. What is that thing that we look for? What's that? Shared side. Is there a shared side there? What's shared between those 2 triangles? LN, right? Everybody see how this one is shared between the 2? So when you have a shared side, what do we say about it? What does the sheet say to do? Yep, reflexive property says that I can say that the segment is congruent to itself because of reflexive. Yes, ma'am. What do you mean? Okay, but do you know if it's a rectangle? How? Do you see right angles? Where? Does it say that it is? Can't assume anything, can you? Okay. I know where you're getting at, but we can't say for certain. Okay. So here, now you go back and you look at your diagram. Okay. Do I have all three sets of sides congruent? Yeah. So that means I have all three sides that are congruent, which means now I can say that my triangles that they're telling me to prove because of side, side, side. All three sides are congruent. That's what a triangle proof looks like. They're much easier than those 7 and 8. Much easier. Yes, sir. It's congruent to itself. So I've already used 1 tick mark for 1 set of sides. I've used 2 tick marks. So I'm just going to use 3 tick marks. You don't have to use 3 tick marks. Sometimes what people might do, oops, I can grab that. Sometimes people do this. It's just denoting that it's congruent to itself. That's all. Yep. Nope. You're done. 4 steps. And really, if you look at it, you are told what you have to prove. You're given 2 things. All you had to figure out was that reflexive property and by which method is it being done. So in a proof like this, if there's 8 things that you might have written down, you knew 5 of them. You knew over half of them. It's pretty quick. Okay, it's pretty quick. The other method is called side angle side. Now, look where that angle is when I write out the word S, when I write out the letters SAS. Where is that angle? In the middle. It's between the 2 sides. So we call that, and we call it an included angle. So if I have these 2, it's the angle between sets of congruent sides. So this is called side angle side, and the angle is between the 2 congruent sets of sides. The angle is between the 2 sets of sides. So let's add that to our ways to prove box that we had. And we have that on there. Hey, just not to get too far ahead of ourselves, but what do you think AAS stands for? So it goes angle, then an angle, then a side. What do you think ASA stands for? Angle, side, angle. The side is between the 2 sets of angles. What don't you see? Because we know that there is no AS in math. There's no AS in math. That's why it's not there. There is no way you can, there's nothing that you can do to prove that there's an AS in math. There's no AS in math. Let's say it, there's no AS in math. Yeah, there's no AS in math. There is no such thing. There is no way of showing that triangles are congruent because of what's called angle side side. There is no AS in math. Okay? All right, just so we know, there is no AS in math. So as we get through this, we'll see that, okay? Again, remember, it depends on the type of problem that you're working with as far as what you're going to wind up working with, how you're going to show it, how it's going to be proved, but it's super, super straightforward. So let's try this one. No, I want to do this one. Easy. This one. Yeah, this one. We'll do this one. One that has a progression to it. All right, take a second, write it down, draw the picture. start by always going with your givens. In this case here, we are given AB is congruent to CB. So we go to our diagram, we mark it. Well, is it already marked for us? All right, so just make sure it's done and safe. All right. Which means we go to our next given. Our next given says D is a midpoint of AC. All right. According to my progression sheet now, what does it say to do when you have a midpoint? Segment equals segment or segment congruent to segment. Okay. Well, we're talking about congruency here with triangles. So what should I say? Congruent, right? Yeah. So I go to my diagram. If D is the midpoint, what are the two segments that are congruent to each other? Well, that means it's AD and, guys, say DC or CD. Does it really matter? So I'll say that AD is congruent to DC. What's my reason? There you go. Definition of midpoint. You were given something that had a definition. You used that definition. You marked the diagram. So now you've got two things done, and you have to figure out a way of showing the triangles are congruent. Well, you only know two ways as of right now officially. You know side, 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 and side, angle, side. I see nothing in this problem that allows me to talk about an angle. Do you? Which means, what do I have to write out? So it means I've got to get the side, 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 but I'm missing a side, aren't I? DB is congruent to, because it's shared side, which means it is, what is it? It's congruent to something. What's my reason? Very good. There you go. Reflexive. Do you have now all three sides? Okay, so now you can see the triangles are congruent. Triangle ABD, what they're telling you to look for, and triangle CBD. And what's your reason? Side, side, side. Very good. Use the progression to get you there. Okay. Use the progression to get you there. Pretty quick, isn't it? Am I right in saying that it's easier than segments and angles? All right. Okay. You guys do this one. Take a couple minutes. I know I've mentioned this before with you guys. Whenever you have multiple givens, especially multiple givens that have progressions to them, take care of the progression first before you go to the next given. That way you don't forget something. So I'm assuming pretty much all of you started the problem like that. Okay? Well, according to your progression sheet, what is a midpoint? If you're given a midpoint, what does it say to do? Equal or congruent? Yeah, segment equal to segment, or segment congruent to segment. So B is midpoint of AE. Look at the diagram. Well, here's B, midpoint of AE, which means these two have to be the same. So I write it down because that's what it tells me to do. AB congruent, BE. Definition, midpoint. Okay? Have I fully utilized that first given statement? Yes. I go to the next one. Now, if you put those both down first, that's okay, but then you have to remember to make sure you state something about both those given statements. So back to the diagram. Bless you. Back to the diagram. B is also the midpoint of DC. So I look at my diagram. Those two have to be the same. So I write it down. Again, same thing, definition of a midpoint. All right. Now I have to sit there and think. There's only two possible ways that I know how to prove triangles that are congruent right now. I have to have all three sides the same, or I have to have two sides and the angle in between them be the same. What do we say? Now, is there any way possible, or excuse me, the only way that we can get the third side that we know for certain is if we had a side that was overlapped. Now, is side AD and CE overlapping one another? No, so I know I can't do that. But also on your progression sheet, you should have a picture that looks something like that. Yes, ma'am? No. Nope. Because. Do you agree that these are the same size? So let's say this is an isosceles triangle. You okay with that? So the sides can stay the same between two triangles, but I can adjust the angle where the sides can be different. That third side can be different. Is there more of that? So no matter as you're going, I'm trying to think if I have another. Sure. Well, here, I got an idea. Watch this. It's very easy to show on this board. Do you agree that these four sides are all the same? Yeah. Okay. So you're only going to put your side here, right? Okay. See where I'm going with that? What's changing? What changes? The angle in here changes. Right? So the angle in here changes. These two sides can always be the same. The third side is always dependent on the angle. So if the angle in between is the same, then that third side. That's why this works. Does that make more sense now? Okay. So back to this one. You have a picture on your progression sheet that looks something similar to that, don't you? Vertical angles, right? Everybody see that? On your progression sheet, you should have a picture that looks somewhat similar to that, and it says look for vertical angles. Well, aren't those two angles the same? Yeah. So we have to label them. I can say that it's, if I say angle ABD, follow the tick marks. If I say angle ABD, what has to be the corresponding angle on the other side with the correct letter? And if I say angle ABD, what has to match on the other one? ABC. ABC. I went 1 to 2. I have to go 1 to 2 that way. I have to do the lettering the same way. Lettering, this is where I was saying before, guys. Lettering has to match. Yep. But all you have to do is mark the diagram. Follow the letters. Once you mark the diagram and follow the letters, you're hard pressed to screw up. And the reason we know that this works is because vertical angles are congruent. So going into this problem, so far, we had 5 steps. 4 of them were givens and progressions. The 5th one, there's a picture of it on your progression sheet telling you what to do. So quite honestly, the only part so far you had to try to figure it out on your own, how do the letters match? So of these first 10 things you wrote down, only one of them you had to think about. The lettering match. That's 10%. 90% of the stuff is on that piece of paper. You'll never get that wrong. Now you've got 2 triangles that are congruent because of side, angle, side. So you write it out. ABD. Yep, almost done. And now Remember I was saying before also that you have to put symbols in front of three letters? This is why you have to put symbols up. We have to say that it's an angle, or we have to say that it's a triangle. You can't just leave three letters there. It won't work. If you don't tell me what it is with three letters, I won't know, nor will anybody else. I don't know if you're talking about a plane, I don't know if you're talking about an angle, whatever. So that's why we always put symbols in front of angles or triangles. That's why we always do that. Whereas segments, we don't put the bars above the segments. Okay, another one off of a progression. Another one off of a progression for us. So now we're given perpendicular. We're given perpendicular, which means you have to look at your progression sheet. What does it tell you to do when you're given perpendicular? Yeah. When you're given perpendicular, especially now that we're dealing with triangles, that means we're going to have to talk about the two different steps. It's literally verbatim off of your sheet. BB, perpendicular, AC. Given. Which means in my diagram now, or according to my progression sheet, I have to say what angles are now the right angles. So if I look at my diagram, that means it's perpendicular here. So I have to state that angle ADB and angle CDB are right angles. Definition of perpendicular. That's what it tells me to do. Read it line for line off of the progression sheet. After you did that, according to your sheet, it now says state that the right angles are congruent to each other. Okay? Once you have right angles, now you can say that angles ADB is congruent, CDB, all right angles are congruent. When you're given perpendicular, that means there's three things we're going to write out. Given, definition perpendicular, and all right angles are congruent. Right off the list. You don't have to try to think. I've now fully used up that, so I go to my next progression. It says AB is congruent to DC. So what should I do to my diagram? Tick marks. Good. I need to prove that triangles ADB and CDB are the same. What am I missing? What's that? What am I missing? I have a side and an angle. What am I missing? Side. Where's the side that I'm missing? Because isn't it shared? That should be the exact same picture of the what you have on your progression sheet. It's a shared side, guys. Are the triangles congruent? Because of what? No. You can only way to show triangles for proven or one of these. And now I think they told us to say triangle A, D, B. Thank you. If you go back and look at those steps, all the things we just did, there are 12 things on there. The first 6 of them came from the first given. Everything was off of your progression sheet. The next 2 steps, the ADs congruent to DC, was given. So now if you really think about it, the first 8 steps you did not have to think about. Okay? The first 8 steps were right off of your progression sheet. The only thing you had to think about, was how do you get that third side here? What was it called? And by which? That means that 9 out of the 12 pieces that are on that proof are basically on your sheet of paper. Okay? 75% of the proof is basically given to you. Okay? There's only 25% of it that you had to think of. How do you get that extra side? And by which method? Now remember, in order to prove triangles congruent, you only know 2 things. If you put something else after triangles being congruent, it's wrong. It's got to be one of these 2. But you have to look at your diagram to figure out which of the 2 it winds up being. Okay? I have 4 of these for you this evening. It's in the book. It's on page 230, section 4.2. Okay, 9, 10, 16, 17. This is a textbook. You guys want a picture of it. But again, guys, it's the same complexity we're working with. There's nothing, there's no tricks, there's no gotchas, there's none of that. It matters if you draw the picture, mark the diagram. That's page 230. So it's here, you want to take a picture?